Greetings and welcome to our virtual poster session. If they build it, they will learn a great ball contraption experience. My name is JD Ferries-Rowe. I am the head geek and Lego enthusiast in residence at Brebeuf Jesuit Preparatory School in Indianapolis, Indiana. When we as a school set out to design a digital citizenship course that would encompass all of the ISTE standards, we met with students, librarians, teachers, even a few administrators, and we brainstormed. And as we thought about it, we kept coming back to a few challenges that we faced that might be problems of education's own making. Our students didn't come into our school with a lot of hands-on experience. And the hands-on experience that they did have seemed to be more of a follow the recipe type experience. There was a tendency to reward replication and to approach original solutions with skepticism at best and sometimes ridicule. It seemed to us that the ISTE standard about innovative designer was the solution to this problem if we could figure out how to approach it right. But what we needed was the authentic problem that those students could solve. What would challenge those students to break out of their school imposed constraints? Enter the Great Ball Contraption. The Great Ball Contraption, or as it's known at conventions and now to our students as the GBC, is a mainstay of Lego and amateur engineering conventions. Challengers are asked to follow a standard, but to use their own creativity to create a Lego brick and motor machine that can transport balls from one end of a device to the other and make it a part of a great Lego chain. Our authentic problem, our challenge, was to use the Great Ball Contraption as a Trojan horse that would teach students how to design, innovate, prototype, and develop that capacity to deal with challenges. This virtual poster details our journey.
Was trying to work together in order to create a concept that would allow a small ball to carry from one side of our project to the other.
The GBC project was definitely the most frustrating of all the projects in that class, just because of how demanding it was, and if you just changed one little thing, it changed the whole project.
On its face, the task is deceptively simple. Students design an in-basket, a method of moving balls from the in-basket across their device to an out-basket, which is actually the in-basket of the next group's contraption. Each group is given a base plate, a Lego motor, and access to the community supply of about 40,000 Lego and Technic pieces.
The cool thing about that project is you're taking something very familiar to them, a Lego. You're adding something new that they're learning, all right? So they're not just completely learning from scratch here. They get pretty free rein on how to do it. I purposely really don't show them a whole lot of examples when I do it.
We were tossing something. We were using some kind of catapult thing. It involved a catapult, I remember that much. We encountered challenges that we weren't expecting to be challenges, and we had some things that were actually a lot easier to solve than we thought they were going to be, and we initially overcomplicated them a lot, and that, I guess, is just normal for engineering anything.
Students are encouraged to follow the steps of innovative design process, including researching and observing, brainstorming, prototyping, and iteration of their ideas based on experience, feedback, and reflection.
Oh my god, it's so close to hitting him, but every single time it misses.
Communication happens within groups, between groups, and even between class periods.
But in the GBC, you all had to work together, and if one thing didn't work, you had to brainstorm to come up with different scenarios and think of what you could do to fix that problem. And you might go a completely different way than what you started out with. My group did, but you just have to keep trying until you get it.
Then they absolutely love it then, at the very end, when we put a bunch of tables together and then try them all out. They love that. That's like an exciting day for them.
Thank you so much for watching this introduction. We have some more pictures, resources, and reflections throughout the poster. If you would like to join JD live, he will be available on Thursday, December 3rd at 4:30 Eastern, 1:30 Pacific. Have a great conference.